Hi dear friends, welcome to BYJU'S Exam Prep and I welcome all for this GATE AIMER'S series of computer science. Okay, it's a GATE free crash course for computer science students and we are dealing with discrete mathematics. And the topic for today is, or today's topic is graph theory, my dear friends. So let us start with graph theory. Okay. See, this is my Telegram group where you can find the information, material, PDFs related to the courses or the topics which I take on Telegram group, my dear friends. Right? And take a step towards the success in GATE. You can get up to 90% scholarship on prep programs of BYJU'S Exam Prep, my dear friends. And you can sign up or log into this BYJU'S Exam Prep app where you can find the details about this scholarship program, my dear friends. It happens very regularly, my dear friends. Okay? Okay, this is about me, myself, Sridhar Dhulipala. I am having 20 plus years of teaching experience. I am associated with BYJU'S from past 1.5 years. I was working on this particular project called Recorded Gate Content, the first of its kind. We created visualized animated content for you. Under BYJU'S Exam Prep app, the category name note down, learn with video lessons. You can find all these video lectures which were recorded by me. The subjects are like engineering mathematics for all branches and for computer science student, discrete mathematics, algorithms, C programming and data structures were recorded by me, my dear friends. Okay. So this is about me. Now, let me start with today's topic, that is graph theory. See, one of the interesting and scoring topic in GATE is obviously discrete mathematics, and in discrete mathematics one of the important topic is graph theory. So let us take up some problems on graph theory, my dear friends. Let us take up some problems on graph theory. Of course, I'll be explaining the ideas together with the examples, so that we can understand the concept as well as how we can actually solve the problems. Am I clear? Look at this graph, my dear friends. See, graph means what? It is an ordered pair of vertices and edges. See, a graph is simply an ordered pair of vertex set and edge set. So each edge is identified with two vertices. Okay, see, if the vertices are not ordered, then you call it as undirected graph. If you identify each edge with an ordered pair of vertices, then you call it as a directed graph or simply digraph. Most of the, hi Lalit, very good evening. Not seen regularly, you people. Now, this is about the graph, my dear friends. See, in graph, mainly what will be there? What will be there, sir? In graph, what will be there? Vertices will be there, edges will be there, and one more interesting concept is degree of a vertex. Degree of a vertex. You will be seeing what is known as degree of a vertex, my dear friends. So let us see for this particular graph. Okay, let us take the vertex A, vertex B, vertex C, vertex D, and vertex E. Please tell me what is degree of each vertex. Please tell me what is degree of each vertex, my dear friends. Please tell me what is degree of each vertex. See, degree of a vertex is number of edges incident on that particular vertex, counting self loop twice. Because if you have a self loop, that particular edge is incident on the same vertex 2 times. That's why self loop is counted 2 times, my dear friends. Very good, right? For A, degree is 3. 3 or 4? 4, na? You said 3. Okay, 5 you are saying. Oh, very good. Very good. See, 1, 2, 3 and the self loop 5. Very good. And what about B? What about B? B is 3. And C, I'm seeing your answer only. For C, how many edges are incident? 3 edges are incident. And for D, it is 1, 2, 3, 4 and there is a self loop. 4 plus 2, that is 6. and for E it is 1. See, the problems in graph theory are very simple. Even the problems which they ask in GATE examination are also very simple. Only thing is you should know how to solve them, and you should have logical thinking, my dear friends. Common sense. Now one very interesting property we try to develop now. Can you add up all these degrees? Can you add up all these fellows? 5 plus 3, 8, 8 plus 3, 11, 11 plus 1, 12, 12 plus 6, 18. So you call it as sum of degrees of vertices, my dear friends. What is it called? My voice is low. My voice is low. Hello? All of you can hear me? Hello? Is my voice little low? Hello? Lalit? Still it is low? Lalit? Now it's fine. Okay, I'll speak little louder so that you can hear me. No problem. Fine. See, if you add up all the degrees, you're going to get 18. And here in this particular graph, if you count the number of vertices, how many vertices are there? 5 vertices. But that is not very interesting for me. What is very important for me is number of edges. How many edges are there in this particular graph? How many edges? Self loop. For counting it, self loop is counted only once, sir. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges are there. And if you observe this, the sum of degrees is 2 times the number of edges. It is not the accident. It is one of the important rule known as the first theorem of graph theory, my dear friends. What is it? It is the first theorem of graph theory, my dear friends. Hope you understand. Hope you understand. Hopefully there is no issue. Right. Nice. What are the applications of graph theory? What applications you want? What applications you want? See, there are so many applications, my dear friends. Okay. See, you can talk about your networks, computer networks. There also you use network topologies are based on graphs only. Am I clear? And there are so many problems which are related to your real life stories also. Okay, actually there are so many real life problems which are converted to graph theoretic problem. Actually the graph theory is originated with the real world problem only. Königsberg bridge problem. Okay. See, the graph theory is studied in every branch actually. Networks, like electrical people also uses graph theory. Mechanical people also use, every branch people uses graph theory, and this graph theory is discovered independently many times, sir. That's why the terminology with graph theory will not be unique, my dear friends. Okay, like. Hope you understand. Yeah. So this is about sum of degrees is twice the number of edges, my dear friends. Sum of degrees is twice the number of edges, my dear friends. Hope you understand. And that is one of the important point. There is one more interesting point also we can note down here. This is odd degree. This is odd degree. This is odd degree. And this is also odd degree. And the number of odd degrees will be always even. The number of odd degrees will be always even. That is, we can have number of odd degree vertices equal to even. Even number means either it may be 0, 2, 4, 6, 8. We cannot have any graph with odd number of odd degrees. The number of odd degrees in any graph must be always, yes, always even, always even. So let us take this problem. And if you want to solve this problem, and this is one of the important result in graph theory, you can find many questions based on this in GATE examination. And the question is, the result is, the minimum degree of a vertex is less than or equal to twice the number of edges by number of vertices is less than or equal to maximum degree. See, this is the most important result. You can find number of questions asked in GATE examination based on this result, my dear friends. Even this problem is just based on this result. Here in this particular graph, the number of n vertices is saying, so number of vertices are not known. Okay, see, we are calling, we know this fellow is calling this as n. Number of vertices in this problem, he is calling it as n, my dear friends. N he is calling it. So here, if you see edges, how many edges are there in this particular graph, sir? 25 edges are there in this particular graph. Very good. Maximum. That is the maximum possible number of vertices. Very good, Lalit. So, here what is that you are having? Delta less than or equal to 2e by n. He is asking about n. N should be less than or equal to 2e by delta. And what is the minimum degree? He says that each vertex has degree at least 3. That is minimum is 3. That is minimum degree is 3, my dear friends. So using this you get n less than or equal to 2 into 25 divided by 3. See, whenever you are looking for integer value less than or equal to something, you should always take the floor of it, my dear friend. You should always take the floor of it. So what is the answer, sir? It is 50 by 3, 16 point something, because you are looking for integer value. 16 is the answer. So what is the maximum number of vertices in this particular graph? What should be the maximum number of vertices in this particular graph, sir? It should be 16. Very good, sir. Very, very, very good. Now, computer science students, we are going to have a very good surprise, my dear friends. You will be seeing this particular surprise very soon. Okay, we'll be getting new faculties on board. Am I clear? And our computer science team is going to become very, very, very strong soon. Okay, so keep subscribe to my Telegram channel as well as BYJU'S Exam Prep Telegram channel, where you will get the best faculty in India only at BYJU'S Exam Prep app. Right? Okay, let us take this problem, my dear friends. Now let us take the following problem. A graph consists of 4 vertices, each of degree 3, and an isolated vertex. Then number of edges is 1. Simple, direct. See, this fundamental theorem you use many number of times in GATE, my dear friends. Okay, not only GATE. Yes, soon. Okay, keep visiting BYJU'S Exam Prep soon. Very, very soon. Okay. Right. Tomorrow I'll reveal some more, the date and all and so on. Okay. I'll give you time. Please try this. Lalit Babu. Lalit, you can try. Nitish, very good beta. Super, बहुत बढ़िया. Rocking. 6, wonderful. See here, there are 4 vertices, each of degree 3. That is degree of each vertex 3. So I'll go for sum of degrees of vertices. 4 vertices, each of degree 3 means what should be their sum of degrees? That is 4 into 3. And there is an isolated vertex. Isolated means 0 degree vertex. So sum of degree will be 0. And this should be equal to twice the number of edges. So 12 is equal to twice the number of edges. So E is equal to 12 by 2. That is 6, my dear friends. That is 6. Super. Very good. Agla samasya. Next problem. Try this. Done. D. Lalit says D. Let us see this. The number of vertices in a undirected graph with 27 edges. Number of edges given to you, that is 27. 6 vertices of degree 2. So what I do, I go for sum of degrees of the vertices. 6 vertices of degree 2, that is 6 into 2, 12. 3 vertices of degree 4, that is 3 into 4, 12. And remaining we do not know of degree. Remaining how many? Let us say x of degree 3, so 3x. And this should be equal to twice the number of edges. He is asking the number of vertices in this particular graph. Okay. So this can be simplified like 24 plus 3x is equal to 2 into 27, that is 54. That is 24 plus 3x is equal to 54. Yani 3x is equal to 30. Yani x is equal to 10. See, this x represent number of vertices of degree 3. So if you count number of vertices in this particular graph, there are 6 vertices of degree 2, 3 vertices of degree 4 and 10 vertices of degree 3. So total number of vertices would be 19. Wonderful, Ritesh. Ritesh, your answer is number of vertices of degree 3 you given, not for number of vertices of degree all the number of vertices. You not given the answer for total number of vertices. Okay? Right. Now comes degree sequence. Degree sequence means we are writing sequence of degrees in a non-increasing order, starting from highest to lowest. That is actually decreasing order with equal fellows together. It is a decreasing order with equal fellows together. Starting with highest degree, we are going to write. You have to tell which of the following can be degree sequence of a simple graph. Nowadays, there is something like, multiple select questions. So, please verify your answer. Please verify your answer, my dear friends. A, B, very good. See, A is obvious. See, actually, every time you don't have to use Havel-Hakimi algorithm. If you can draw a graph with this, that is simple graph with this, obviously it is a degree sequence. Because all degrees 2 means it should be a cycle, 4 cycle. So this is ready. What about this? Let us use Havel-Hakimi procedure. Those who know, fine. If you do not know, I'll explain with this example. Follow this. Maybe I'll explain with C. It is easier to get the idea. Then we'll go for B. So let me take C example first. 4, 3, 1, 1, 1. What is the highest degree vertex in this, sir? Highest degree vertex is 4. Remove this highest degree. What is that value? 4. From 4, that is from remaining 4 degrees, you subtract 1. Remaining 4 degrees, you subtract 1, my dear friends. You can say 2 regular graph, obviously. Correct? Pavi, very good. Correct. Correct, Pavi. Now what happened? This is 2, this is Shunya, this is Shunya, and this is Shunya. Now what you do? Again start doing the same work. Highest degree vertex is what? 2. You remove 2 from next to 2, you have to subtract 1. But when you subtract 1, what is happening? You are getting negative value. Whenever you get negative value, you have to stop the process, and it is not graphic. It is not graphic. Not graphic means you cannot draw a simple graph with this degree sequence, my dear friends. You cannot draw a simple graph with this degree sequence, my dear friends. Okay? Is the idea clear? All of you able to follow? Next, what about D option? 5, 4, 3, 2, 1. What is highest degree, my dear friends? 5. From next to 5, you have to subtract 1. But there are no 5 degrees. Because we need 5 to subtract 1. We need 5 numbers or 5 degrees to subtract 1. But we are having only 4. That is what we call it as not enough degrees to perform the operation. Not enough degrees to perform the operation. Therefore, we say that it is not graphic. Now, let us see the next one, that is option B. What about option B, sir? Okay, we don't have space. Okay, you can do it here itself. Seven, 6, 6, 4, 4, 3, 2, 2. Highest degree is 7. From next 7, you have to subtract 1. So what happens? It is 5, 5, 3, 3, because next 7 only. 2, 1, 1. And you have to rearrange in the correct order. Luckily, it is in the correct order. Highest fellow is 5. Next 5 you have to subtract. Next 5 only you have to subtract 1. So what happens? It is 4, 2, 2, 1, 0, 1. See, here the order is changed. After 0 you are getting 1. So you have to write it in the decreasing order. So rearrange it. That is 4, 2, 2, 1, 1, 0. Highest fellow is 4. Next 4 you subtract 1. So what happens to this? 1, 1, 0, 0, 0. And once you got this, you can easily say that 1 you remove. Next 1 you next 1 you subtract 1. So it becomes what? 0, 0, 0, 0. So because of this, what happens? It becomes graphic. So this is also a graphic. Graphic in the sense, you can construct a simple graph with that degree sequence, my dear friends. You can construct a simple graph with that degree sequence, my dear friends. Hope you understand? Like that. So here A and B are graphic. These two are not graphic. Solve this problem, simple problems. So I am giving some simple, some interesting questions also. Very good. See, one should know this particular formula perfectly, my dear friends. Number of edges in a simple graph. Okay? With 10 vertices. Actually, simple graph, that is maximum number, na? Complete graph with 10 vertices. Actually, I missed it. All of them can be possible, sir. All of them can be possible. Sorry, complete graph. Or you can say complete graph. I need to say, I forgot to mention that. Sorry, printing mistake happened. Number of edges in a complete graph with n vertices. Number of edges in a complete graph with 10 vertices. So the number of edges in complete graph is given by, with n vertices, we denote it by kn. Complete graph with n vertices is denoted by kn. And that is given by the formula n into n minus 1 by 2. So number of edges in K10, because it is complete graph with 10 vertices, it is 10 into 10 minus 1 by 2. That is 5 9s 45, my dear friends. What is the answer? 45. Yeah, but that should not, because even 28 also can be correct, na, simple graph. Maximum it can be 45, no? So all of them can be correct. See, if at all he says all of them can be correct. Minimum is what? Because 10 is there. Connected, when you say minimum can be 9. Connected means 9 should be the minimum for connected graph. Maximum should be, because 10 vertices are there. What is the minimum number of edges in a connected graph? Minimum connected graph. Lalit, I am saying connected graph. Minimum is 0, I understand. Yeah, minimum is 0. I am saying connected graph. Yeah. If not connected, minimum can go up to 0 also. Minimum can go up to 0 also. Yes. Now you answer this question. There are 2-3 questions involved in this simple question. Please answer this question. Answer the question, my dear friends. Answer the question. 32. Huh? How? Wrong answer. See, in graph theory, questions looks very simple, sir. But there may be something involved in it. You have to be very careful. See, my dear friends, first of all, you know, maximum number of edges in a labeled simple graph with n vertices. Maximum number of edges in a labeled simple graph with n vertices. What is the answer for this? So the maximum number of edges in a labeled simple graph with n vertices would be n into n minus 1 by 2. So if you are having 5 vertices, maximum edges would be, what would be maximum edges? The maximum edges would be 5 into 5 minus 1 by 2. That is 10 is the maximum number of edges. So maximum possible edges would be 10. You can select 0 edges, that also creates a simple graph. 1 edge, that also can select or create a simple graph. But what is that you want? You want simple graph having 4 edges. You want simple graph having 4 edges. So number of labeled simple graphs having or on 5 labeled vertices, because we already mentioned labeled, now you can say 5 vertices. 5 vertices having 4 edges would be what? So from total 10 edges, you have to select 4 edges. No, why 2 power 10, sir? Why again 2 power 10, sir? It is just 10C4, that's it. 10C4, that's it. You just select the 4 edges. You just select the 4 edges, that's it. You just select the 4 edges, that's it. That will create a simple graph. No need of arranging, na? No 2 power, sir. No 2 power business. 10C4 is the answer. See, if you want total number of simple graphs, if you want total number of simple graphs on n labeled vertices, that is given by, yeah, that's what I am trying to tell you here. That's what I am trying to say. See, I'll tell you, see Lalit Yadav, see this very simple story. See, suppose you are having 3 vertices, sir. Let us take simple story. 3 vertices are there. See, with 3 vertices, maximum you can have 3 edges. Maximum you can have 3 edges. Correct or not? Maximum you can have 3 edges. But you can create a 0 edge graph. You can have a 1 edge graph. You can also have 2 edge graphs. You can also have 3 edge graphs, my dear friends. So how many 0 edge graphs will be there? 3C0. How many 1 edge graphs will be there? 3C1. Because out of 3 edges possible, you have to select 1 edge. Hello, Kaustubh Nageshwar. Out of 3 edges possible, you have to select 1 edge because it is a 1 edge graph. So similarly, how many 2 edge graphs will be there? 3C2. How many 3 edge graphs will be there? 3C3. That will give you the total answer. Similarly here, if you want to find total number of simple graphs on n labeled vertices, the total formula is 2 power n into n minus 1 by 2. But if you want to get this in a different way, you have to find number of 0 edge graphs. You have to find number of by 2 I'm missing. Number of 1 edge graphs. You have to find and so on. Number of n into n minus 1 by 2 edge graphs, my dear friends. Oh, if not labeled, you have to draw and check it. There is no direct procedure for that. There is no formula for that, Lalit Yadav. Unlabeled. See, labeled is very important. Otherwise, it is shootout. Okay? See, unlabeled, you have to draw it. You have to draw and check. For example, there was a question in GATE. Number of simple graphs on 3 unlabeled vertices. Then you have to check that only. Because 3 unlabeled vertices means this is 0 edge graph. Because here I am not putting label. Actually, here I need to make the labels actually. Only to explain the idea, I not put the labels actually. Here it is a labeled graph I was talking about. If it is unlabeled graph, only 1 0 edge graph. If it is unlabeled graph, only 1 edge graph. Only one edge graph. Suppose if it is labeled, na? If it is labeled, 1, 2, 3 is there. This is one fellow. This is another fellow. This is another fellow. Here we are counting this labeled graphs. People have this particular confusion. Some people don't even know that what problem they are solving also. They don't even know the difference between a labeled graph and unlabeled graph. Okay? Need to know that. These are the minute things, my dear friends, which makes lot of difference. Am I clear? Please understand this. For labeled we get 3. For unlabeled we get only 1. For unlabeled we get only 1. Lalit Yadav. Am I clear? For unlabeled we get only 1. Note that. Am I clear? Yeah. See, my dear friends, if it is a full course, I would have discussed so many things. So here I am just trying to give you the recap of the ideas. Okay? Yeah. See, generally I discuss graph theory around 14 to 15 hours. Sometimes it goes up to 18 hours also. Okay, only these types of graphs I discuss around 4 hours. The entire stories, all the types of graphs I'll discuss in my regular classes. Okay? Yeah. Now the next one. Number of edges in a wheel graph. What is a wheel graph, sir? For those who do not know what is a wheel graph is a cycle graph with an additional vertex which is adjacent to all the vertices of the cycle. So it is W3 you call it. Now look at this. 4 vertices. 4 vertices, that is 4 cycle. You are having a 4 cycle. This fellow will have 5 vertices. 4 cycle, that is 4 wheel. W4 will have 5 vertices. W4 will have 5 vertices. W4 will have 5 vertices. So how many edges this fellow will have? 4 plus 4 edges connected to this. So he is asking about W4. 5 vertices means W4. So the correct answer is option A, my dear friends. Not option B. Not option B, option A. 5 vertices means that is W4. 5 vertices means W4. See, for wheel graph the story goes like this. If it is a wheel graph, Wn you represent it. It will have n plus 1 vertices and it will have 2n edges, my dear friends. Because I said n plus 1 is 5, so n is equal to 4. Therefore, the number of edges is 8, my dear friends. Wheel vertex will have degree n, not n minus 1, Lalit Babu. It will have degree n, not n minus 1. Okay, it will have degree n. Next question. Simple graph is called regular graph if all its vertices have same degree, my dear friends. That is what it says. Let G be a connected regular graph. It is a connected regular graph with 22 edges. It is having 22 edges. In the given options, which one is the possible number of vertices of the graph? In the given options, which one is the possible number of vertices of the graph? Now look here, sir. Suppose n is the number of vertices and it's a regular graph means, okay, it is number of vertices. Suppose it is a k regular graph. Therefore, degree of each vertex is k and number of edges is given as 22. That means sum of degrees of vertices will be twice the number of edges. Sum of degrees of vertices will be twice the number of edges. So it is k plus k plus k n times, that is nk should be equal to twice the number of edges because edges is 22. So 2 into 22, that is 44. That is n into k should be 44. Now it is a connected graph, my dear friends. It is a connected graph. So because edges is equal to 22 and G is connected, and edges equal to 22, therefore number of vertices must be greater than or equal to number of edges. Vertices must be greater than or equal to what? How many vertices you should contain? Because 22 edges are there, if it is a connected graph, number of vertices must be at least one more than that. Because tree is the minimally connected graph. Tree is the minimally connected graph. Am I clear? Tree is the minimally connected graph, my dear friends. I think this number is given wrongly in this because 2 is not possible. Connectedness, if it is having 22 edges are there means connected means minimum 23 vertices should be there. That means only possibility is it should have 44 vertices. 44 vertices it should have. 44 vertices means degree of each vertex should be 1. Degree of each vertex should be 1. How is this possible, sir? I think none of them possible. Sorry, this question was little wrong actually. I think there should be something different from this. 44 is coming, but that should not be the case because connected regular graph, even though if it is mentioned, there is something wrong with this. There should be given like either number of vertices or other things are given. Okay, I noted wrongly the problem. Okay, but from the given options, this should be given differently because you cannot find exact number, sir. If you want to find exact number, then it won't be regular. Huh? No, it will be regular, sir. Degree of each vertex is 1 means it can be regular, na? Degree of each vertex. See, 44 is sum of degrees. 44 is sum of degrees. Okay, sum of degrees means what, sir? It should divide that, na? The degree should divide that, na? Okay, I'll leave this. I'll come to this problem again. Let us see the other ones. I think there is some information missing in the problem. We'll come to that. Now, please tell me which one of the following is not bipartite graph. Which one of the following is not bipartite graph, my dear friends? Which one is not bipartite? So none of the options is the correct answer for previous one. Very good. Kaustubh Nageshwar, very good. How you answered that, Kaustubh? How you answered that properly? quickly. And tomorrow is the last one where we talk about the entire counting. Generally, I used to start with counting, but this time I'm doing counting last. Tomorrow I'll do counting. Tomorrow we do counting. Now look here. A graph is bipartite. A simple graph is bipartite if and only if every cycle in the graph is even cycle. That is, in the graph, even if you find one odd cycle, it cannot be. If you find one odd cycle, it cannot be bipartite, my dear friends. What grouping you are talking about, sir? See, my dear friends, here we are having a 3 cycle. Odd cycle. This is an odd cycle. So when you find an odd cycle, it cannot be bipartite, my dear friends. So which one is not bipartite? Option A is not bipartite. Very good, Nitish. Very, very good. Super. Whereas in remaining all, you see every cycle is even cycle. You can directly see this is one part and this is one part. So directly what happened? It is bipartite. And in this, okay, and this is what is happening in this, sir. In this, what is happening? Every cycle is even cycle. Every cycle is even cycle. See, that grouping method will be very, very costly method, Mr. Kaustubh. That is very costly method. Every cycle is even cycle or not. This is the easiest method possible, my dear friends. Therefore, it is bipartite. Here, it is a tree. In tree, what happens? There is no cycle at all. So we can say every cycle is 0 cycle. 0 is even. Therefore, it is bipartite. Every tree is bipartite, my dear friends. Every tree with 2 or more vertices is bipartite. Every tree with 2 or more vertices is bipartite, my dear friends. Please remember this. This is one of the interesting results. Beautiful results. Now let us understand the idea of isomorphism. See, isomorphic graphs are same graphs drawn differently. See, they are same graphs drawn differently. For example, if you see the second graph, you catch here, and you just stretch them out. So what do? You catch these 2 points and you stretch them. All of you able to follow? See, this is how it is. You stretch these 2 points. You stretch these 2 points. So when you do it, you are going to get the first graph or not. That is, by modifying one graph, you can get the other graph. They are the same graphs drawn differently. Then we say that they are isomorphic graphs. We say that G1 is isomorphic to G2. This is one of the very famous question in GATE, my dear friends, which they ask you. They give you the graph and they ask whether these 2 pairs are isomorphic or not. You try to get one graph from the other graph. Of course, they are not of same size, shape, my dear friends. Only thing is they are the same graphs with different labeling, different size, different shape, my dear friend, but they are the same graphs. Then you say that they are isomorphic, my dear friends. So they are isomorphic graphs. So these 2 graphs, because they are the same graphs drawn differently. Same graphs drawn differently. Therefore, they are isomorphic graphs. Am I clear? So the best way to check whether the given graphs are isomorphic is try to get one graph from the other graph. Here what all you can do stretching, you can do rotation, you can rotate to any angle, you can flip horizontally, vertically, all this you can do it. But what is not allowed is you cannot cut paste somewhere. You cannot cut and paste somewhere, my dear friends. Please note that point. Whether these fellows are isomorphic or not, you just need to mention yes or no, nothing more than that. You just need to mention yes or no, nothing more than that, my dear friends. Yes, Kaustubh Nageshwar says yes. Lalit also says yes. See, they are isomorphic, you feel, But I say that they are not isomorphic because in this graph there is a 3 cycle. There is a 3 cycle in this. Can you show me a 3 cycle in this? Can you show me a 3 cycle in the second graph? Can you show me a 3 cycle in the second graph? Can you show me a 3 cycle in the second graph, my dear friends? Any 3 cycle. It's not one. See, that is only necessary condition. That is only necessary condition, not sufficient condition for isomorphism. The sufficient condition is adjacency must be preserved. Adjacency must be preserved. They are not preserving adjacency. Simple adjacency verification here is there is a 3 cycle in the first graph, but there is no 3 cycle in the second graph. You see, every cycle, there is no 3 cycle. Here there are 2 3 cycles in the first graph, but I couldn't able to find even a single 3 cycle here. All the cycles. See, everything must be same. They are same graphs, sir. They are same graphs drawn differently. If you see this example, there are 3 cycles, there are 4 cycles, everything, whatever is there, same thing. Their adjacency also preserved. Everything is same to same. Everything is same to same, my dear friends. Now let us answer this question. Answer this question, my dear friends. See, G be a loop-free undirected graph on n vertices. G has 56 edges and G complement has 80 edges. Then what is number of vertices in the graph, my dear friends? See, my dear friends, we know that number of edges in a graph and number of edges in a complement. See, the complement is defined only for simple graphs, my dear friends. So, even though he not mentioned, you can directly answer this question. Very good, Lalit, very good. Number of edges in G plus number of edges in G complement must be number of edges in Kn. It should be equal to number of edges in Kn, my dear friends. So what happens? Number of edges in, that is 56 plus 80 must be equal to n into n minus 1 by 2. That means n into n minus 1 must be equal to 136 into 2. What is 136 into 2, sir? When you union these two graphs, actually you union these two graphs, you are going to get the complete graph, my dear friends. You are going to get the complete graph, my dear friends. N into n minus 1 must be 136. 136 into 2 is how much, sir? 272. So you need product of two consecutive numbers equal to 272. You need to find product of two numbers, consecutive numbers whose product is equal to 272. So the numbers must be n is equal to 17. If you take 17 into 16 is 272. So answer is very good, Lalit. So n is equal to 17, my dear friends. Very good, Lalit. Super. Cool. Yes. A tree has 4 vertices of degree 2, 1 vertex of degree 3, 2 of degree 4 and 1 of degree 5. How many pendant vertices the tree is having? How many vertices the tree is having? Please answer this question. Sorry. So here also the story is same. Sum of degrees must be twice the number of edges. Sum of degrees means 4 vertices of degree 2, that sum will be 4 into 2, 8. 1 vertex of degree 3, that is sum will be 3. 2 of degree 4, sum will be 2 into 4, 8. And 1 of degree 5, sum will be 5. And remaining of degree 1. Remaining of degree 1. So degree 1 means their sum must be equal to x. That should be equal to twice the number of edges. So 11, 16, 24 plus x is equal to twice the number of edges. Now, if you see number of vertices, there are 4 vertices of degree 2, 1 vertex of degree 3, 2 vertices of degree 4, and 1 vertex of degree 5, and remaining vertices of degree 1. So we do not know how many vertices of degree 1 are there, let us call it as x. So the number of vertices must be equal to 5 plus 6 plus 2, 8 plus x. Because number of edges in a tree will be n minus 1. Number of edges in a tree will be n minus 1. So number of edges from this you get it as 7 plus x. So here we got two relations. Substitute E in this. So 24 plus x is equal to 2 into number of edges, that is 7 plus x, my dear friends. That is 24 plus x is equal to 14 plus 2x. That means 2x minus x, that is x is equal to 24 minus 14, that is 10. 10 is the answer. Oi, what is that n minus 1 plus x? Huh? What is that? Why n minus 1 plus x, Babu? E is n minus 1 plus x. Why n minus 1 plus x, Babu? X is 10. See carefully. See carefully. Got it? Now what happens? X is 10. You got the value of x 10. Then he's asking x is nothing but number of pendant vertices, that is 10. Suppose he asks number of vertices. They can ask you number of pendant vertices, 10. Number of vertices, 8 plus 10, that is 18. If he asks number of edges, that is n minus 1, that is 17. So all this can be answered, my dear friends. You can answer all these questions, my dear friends. You can answer all these questions, my dear friends. The next one, answer this question. Yeah. Answer this question. Is the audio video fine? Any doubts? Any issues with the audio video? Am I clearly visible? See, there is a forest having 7 trees. Tree 1, tree 2, tree 3, tree 4, tree 5, tree 6, tree 7. And total number of edges is 40. But he is asking how many vertices are there in F. My dear friends, because each fellow is a tree, let us assume that there are n1 vertices in the first one, n2 vertices in the second tree, n3 in the third tree, n4 in the fourth tree, n5 in the fifth tree, n6 vertices in the sixth tree, and n7 vertices in the seventh tree. Then how many edges are there in each tree, my dear friends? In each tree, how many edges will be there? 1 less than that. That is n1 minus 1, n2 minus 1, n3 minus 1, n4 minus 1, n5 minus 1, n6 minus 1, n7 minus 1. Sum of edges. So number of edges will be equal to what, sir? So if you add n1 minus 1 and so on, n7 minus 1, you get total number of edges. This will be total number of edges. So what is it, sir? If you add up this n1 plus n2 plus and so on up to n7, minus 1 7 times, minus 7 is equal to number of edges, that is 40. But this is sum of vertices is nothing but number of vertices, because n1 plus n2 plus n3, if you add all of them, you are going to get number of vertices. If you add all of them, you are going to get number of edges. Got it? So this is n minus 7 is equal to 40. So what is the value of n, Babu? What is the answer for n, Babu? Uh, 47. So how many vertices are there in this particular graph, Babu? 47 vertices are there. How many vertices are there? 47 vertices are there. Because each component will give you one extra vertex. Am I clear? So if you want to do it, instead of doing this entirely, by common sense, if you have a single tree, number of vertices will be one more. If you have two trees, number of vertices will be two more. If you have three vertices, we have three more vertices. If you have seven more. 47 directly you can answer. Okay? Common sense also you can use to get the solution. Next one. Next question. Answering the question, we are having a simple graph with three components. Component 1, component 2, component 3. First component is having 4 vertices. Second component is having 5 vertices. Third component is having 7 vertices. The question is, what will be the maximum number of edges possible? See, my dear friend, in each one is a simple graph. Each one is a simple graph. In each, how many? Hello, sir. Very good afternoon. Good evening. Prajwal Nijara, very good, sir. 74 is good answer. So, each component, maximum edges. You know, n into n minus 1 by 2, maximum edges. So, max edges in each component you find out and add them, you will get a required answer. That is 4 into 4 minus 1 by 2, which is nothing but 6. 5 into 5 minus 1 by 2, that is 10. 7 into 7 minus 1 by 2, that is nothing but 21. So, the answer must be 37. Why 74, Babu? They are the component, no? Disconnected. How can you connect them again? How you are connecting, sir? Are you doing like 14 plus 19 into 19 minus 1 by 2? Are you trying to do this? No, that is also wrong. 2 you missed. Very good. 37 is the answer. See, you don't have to do any great things, sir. If you stop doing mistakes, your ranks will be improved by a lot. If you stop doing silly mistakes, I can tell you your rank will be improved by at least 100. If you are top ranker, it will be improved at least by 10. Remember that. Which of the following is not planar? Which of the following is not planar, Babu? Now if you observe, the first one, is it planar? The first one, is it planar, Babu? First one, is it planar? Can you draw without crossover? Yes. You can draw, okay. You can draw this without crossover. Just draw this outside. So this is planar. This is planar. See, we know K5 non-planar. Some people directly answered it. But this fellow, I redraw this for you, my dear friends. It is 1, 2, 3, 4, 5, 6. What I do, I'll keep 1, 3, 5 here and 2, 4, 6 here and redraw this graph. 1 is connected to 2 and 1 is connected to 6. 3 connected to 2 and 6. Actually, 1 is also connected to 4. 3 is also connected to 4. 5 is connected to 2, 4 and 6. 2, 4 and 6, which is K33. And you know that K33 is also non-planar. K33 is also non-planar, my dear friends. So these two fellows are non-planar. B, C are non-planar. Whereas this fellow is planar because this edge you can just draw outside. Without crossover, you can draw that. That is A and D are planar, whereas B, C are non-planar, my dear friends. So let us conclude with one more example, Babu. Let us conclude with one more example. What is the chromatic number of the following graph? What is the chromatic number of the following graph, my dear friends? Chromatic number means what is the minimum number of colors with which you can color this particular graph. That is, you can color the vertices of the graph in such a way that no two adjacent vertices have same color. Try this. And tomorrow we are going to start with what? Counting. Then you will be having a surprise soon. Very, very soon you will be having a surprise, my dear friends. Now what? What is the chromatic number of the following graph? What is the chromatic number of the following graph? Chromatic number. See, my dear friend, for chromatic number, two ideas are very, very helpful. If it is a complete graph, we require n colors. And if it is an odd cycle, we require 3 colors. If it is an even cycle, we require 2 colors. So if you observe here, this is 1, 2, 3, 4, 5. See, you see this odd cycle is there. So when you are having odd cycle, we definitely require 5 colors. So I color this with 1, this with second color, again this I color with 1, this I color with 2, but this I cannot color with 1, I need third color, my dear friends. Because it is a 5 cycle, definitely 3 colors are required. 5 cycle means 3 colors are required. Am I clear? Now can you make up with just 3 colors? Can you do it with just 3 colors? That is the question. So what you do? Try to color the remaining vertices in such a way that no two adjacent vertices are having same color. Because it is 1 and it is 2, here this fellow you cannot give 2 but you can give 1 color here. Here I can give 2 color. Here it is 2 means this I can give 2 color and this I can give 1 color. So I can do this with just 3 colors, my dear friends. See, for complete graph n colors are required. For complete graph Kn, n colors are required, my dear friends. For complete graph we require n colors, my dear friends. See, my dear friends, we are also launching a new series on GATE app, which is called Fundamental Series for 2024 aspirants. Okay, whereas there is a rank booster series happening for 2023 batch students on BYJU'S Exam Prep app. See, we are not just helping you in this YouTube session, sir. We are also trying to help you in app sessions. Please do join BYJU'S Exam Prep app to get more details, my dear friends. And you can download free ebooks from these Telegram groups, which are given in the description box. The GATE free workshops are also conducted very regularly. Please join BYJU'S Exam Prep app to get that information. And also like, subscribe and share this particular session with your friends, my dear friends, those who need. There's a scholarship test to get a very good scholarship up to 90% for preparation concept or topics. Okay. So that's all for today, my dear friends. Tomorrow we come up with counting problems. Okay. Be ready for counting tomorrow at 6 p.m. Till that time, very good night. Thank you, sir.